Algebra Lesson 4-7. And we started off the year and we were working quite a bit on solving equations. And then we switched gears and we started making all these graphs. And what would be nice is if there was some connection between solving equations we were doing earlier and the graphs that we've been making, and in fact there is. We can actually use graphs of equations, and we can use the graphs to solve equations as well. And what would be great is if we could solve them multiple ways. So then we could solve it algebraically, playing the shuffling game, get an answer, and we could also solve it with the graph. The two answers are the same. It gives us a lot of validity into what we're doing, a lot of backup for our answers. So in order for us to do that, I've got some steps that I want to go through. They're pretty easy, and they basically just involve you being able to make a graph. Now remember, you can make a graph using an input-output table, where you get to choose values to substitute in for x and then see what you get for y. You can also make a graph using your x and y intercepts. You want the x-intercept, plug 0 in for y. You want the y-intercept, plug 0 in for x. And most recently we've learned how to make a graph using slope-intercept form, where we have y all by itself. Any of those three methods work, whichever works best for you, but you need to be able to make a graph. So here's some suggestions for step number 1. Write it in the form that we would call ax plus b is equal to 0. Now this sounds a little confusing when we say ax plus b is equal to 0, but I want you to concentrate on this right-hand side. Over here you have nothing. You have equal to 0. In other words, you don't have any x's, you don't have any y's, you don't have any numbers, you have 0 over there. So what I'm trying to say is just get everything onto one side. Play whatever game you want and try to get everything onto one side so that it equals 0. If you get everything over to one side equals 0, you're in good shape. That's step number 1. This may already be done for you. It's possible that the equation is already written equal to 0. But if it's not, play the shuffling game and move everything onto one side. Step number 1. Step number 2, write it into function form. Now if you look at this here in the green, ax plus b equals 0, and you look at this in the blue, ax plus b equals y, the only difference is this 0. You replace the 0 with the y. There couldn't be a more easy step than step number 2. Just get rid of that 0 and replace it with a y. And I'm going to explain why that's the case. In other words, replace the 0 with a y. Okay, so we've got some basics. Get everything onto one side so it equals 0. Then replace that 0 with the letter y. Once you've done that, you've created y equals mx plus b. You should be able to make that graph relatively easy now, y equals mx plus b. Exactly the same, even though it says ax. Someone's going, oh, that's a just stood for a number. And the number that's in front of the x is your m, your slope. The b is still your y-intercept. Alright? So we get it equal to 0. We replace the 0 with a y. That gives us slope-intercept form, which means we have a starting point on the y-axis and a slope to go up and over, and we're good to go from there. What we want to do when we solve this is we want to look at where the graph crosses the x-intercept. Now this is what's important. The x-intercept. When you have an x-intercept, it means you are on the x-axis. Say you are right there. That would be considered an x-intercept. And when you're on the x-intercept, you haven't gone up and you haven't gone down. So what's your y value at that location? When you're at an x-intercept, your y value is always equal to 0. Remember, we replaced the 0 with the letter y. In other words, we're saying when y is 0, what does x equal? So we're looking for where our graph will cross the x-axis, because that's when our y value is 0. So it all comes back in. So let's try that out. First we're going to solve this algebraically. We're going to actually play the shuffling game. This says negative x minus 3 equals 0.5x. We're going to get an answer by playing the shuffling game. So I'll go ahead and I'll write that as negative 1x plus negative 3 is equal to 0.5x. Now you can certainly play the shuffling game as it is. It does have a decimal, so you can multiply everything by 10, and you would move this over and make it 10, this over and make it 30, and this over and make it 5x. Or, because it's just a 0.5, you could also multiply everything by 2. It's a little smaller, but multiplying 0.5 by 2 gets rid of the decimal and makes a whole number. But you must distribute it to everything. So I actually am dealing with negative 2x plus negative 6 now equals positive 1x. And if I want to solve, I'm going to get all the x's onto one side. So I'm going to add 2x over here, which now gives me a situation of those canceling out. Negative 6 equals 3x. All I have to do is divide by 3. And x equals negative 2. I am hoping when I get done making this graph that my graph crosses the x-axis at negative 2. If my graph crosses the x-axis at negative 2 when I've followed all the steps, then I'm in good shape. So let's go back to it and let's try graphing. Graphing, the equation was negative 1x plus negative 3 was equal to 0.5x. Now again, according to step number 1, we want to try to get everything onto one side so that it equals 0. And you can certainly do that at this point, or if you are more comfortable dealing with these type of numbers that are whole instead of, or integers instead of this decimal, you can still multiply everything by 2. So we can multiply everything by 2 as we did before, here, here, and here. We now have negative 2x plus negative 6 equals 1x. And all you need to do is move this over here and it'll be equal to 0. It might be easier for you to move it with whole numbers or integers. So we add negative 1x to both sides. Those cancel out. We now have negative 3x plus negative 6 is equal to 0. I basically have done step number 1. Step number 2, this is step number 1. Step number 2, I must replace that 0 with the letter y. So negative 3x plus negative 6 is equal to y. I'm going to reverse it. I'm just going to switch the equal sign and everything around. It's exactly the same as y equals negative 3x plus negative 6, which means you have y equals mx plus b. You have your perfect slope-intercept form. In order to see the slope a little better, let's put it over 1 so you have your rise over run. We are going to start on our graph at negative 6, because that's the y-intercept right here. And this is the slope. That's why it's called slope-intercept form. It has those two pieces of information. So negative 6, 2, 4, 6. That's my y-intercept. I then go down 3 and right 1. If I go down 3, 1, 2, 3 and right 1, and down 1, 2, 3 and right 1, I'm not getting very close to the x-axis. I'm getting further and further away from the x-axis, and my whole objective is to figure out where the graph crosses the x-axis. I could keep going down 1, 2, 3 and over 1, but I'm not going to get closer. Remember, down 3 and right 1, rise over run, is exactly the same as going up 3 but going left 1. They're the same. So I could go up 1, 2, 3 and left 1, 1, 2, 3 and left 1, 1, 2, 3 and left 1, and I've now definitely crossed the x-axis. In fact, I've crossed the x-axis exactly where I thought I would. Right there is where I've crossed the x-axis, which is the exact same answer that I had before. This was step number 3. Graph the y equals mx plus b. So whether I solve it with an equation, playing the shuffling game, or I solve it graphically, I get the exact same answer that is x equals negative 2. Alright? Now we're going to solve this one just graphically. It does look a little bit scary because of the mixed numbers and improper fractions involved. It's okay. I'm not going to worry about the algebraically part. I'm going to change this to plus negative 1. I'm still going to do everything I've done before. Now, what's interesting is these both have 2's. Common denominator. If I want to get rid of a denominator, I'm going to multiply the entire equation by a common denominator. What's more common for 2 and 2 than 2? So I'm going to multiply this entire problem by 2. And when you multiply it all by 2, it's going to multiply here by 2, it's going to multiply here by 2, and it's going to multiply the other side by 2. Everything has to get multiplied by 2. When this multiplies by 2, they cancel out, leaving me with 5x. When this multiplies by 2, it's going to give me negative 2. When I multiply by the 2 over here, the 2 over 1 cancels out with the 2 on the bottom, leaving you with 9x. So this is so much easier to deal with when I've gotten rid of those common denominators. Now, according to step number 1, I need to get everything onto one side. So I'll add negative 9x to both sides. Consequently, someone might say, how come you never move into the right? You could. I just don't want to move the 5x and add the 2. It's 2 steps when all I got to do is move 1 step. So those cancel out here. negative 4x plus negative 2 is equal to 0. So this was all step 1. Step number 2 says replace the 0 with the letter y, which because of the way we've written it with the y on the other side, sometimes people think it's different. I'm just going to reverse it around and say y equals negative 4x plus negative 2. That is step number 2. I've replaced the 0 with the y. And I have y equals mx plus b. What's great is you can write this as a fraction and you now have your slope. So there's my y-intercept. So y-intercept is right here. And this is my slope. I go over to the graph and I put a y-intercept at negative 2. Negative 2 is right there. Y-intercept. From there I'm supposed to go down 4 and right 1. Down 4 is going to take me off the graph and away from the x-axis. I don't really want to go down 4 and right 1. Thankfully that's equal to going up 4 and left 1. So now I can go up 4, 1, 2, 3, 4 and left 1. 1, 2, 3, 4 and left 1. But what you'll notice is when I go to make this graph, it's not easy to tell exactly where it's crossing. I can guess. That's one of the drawbacks of doing my graph to solve the equations. Maybe I'll make it a little bigger. Let's go back. And instead of putting my y-intercept there, what if I made my increments a little bit bigger on the y-axis and said that's negative 2, so that's 1, 2, 3, 4, 5, 6, 7, 8. So now the increment's a little bit more spread out. I might get a little bit more detail. And I'm going to spread it even more on the x-axis. 1, 2, 3, there's 1. 1, 2, 3, there's negative 1. There's negative 2. There's negative 3. I just have to be careful that I make sure I move the proper amount each time I use my slope. So I'm still at y-intercept at negative 2. But now my slope says to go, instead of going down 4 and over 1, we'll say up 4 and left 1. If I got to go up 4, that's 1, that's 2, that's 3, that's 4. And remember, going left 1 puts me here. Someone might, you went 4 places. No, I only went 1 because of the increments I used. Next I go up again 4. So 1, 2, 3, 4, and I go left 1. And if I've done it correctly, I should make a nice straight line. If my counting's a little off, which is possible, then it won't make this straight line. But it does. It makes a nice straight line. And what I'm looking for is right there. It appears as if it's crossing the x-axis at x equals negative 1/2. So therefore, that is my solution to this crazy equation. All right? If you take 9 and you multiply it by negative 1/2, you're going to get negative 4.5. If you take 5 and you multiply it by negative 1/2, you're going to get negative 2.5. And when you add negative 2 to that, you get the same answer, negative 4.5. It works. And it would work up here, except that it's more complicated because of those improper fractions. So again, the rules: make it equal to 0, get everything onto one side, replace the 0 with y, graph y equals mx plus b, and wherever it crosses the x-axis, that's your answer.